So right now we're going to talk about infinite series. So a series is simply the sum of a sequence. And sum, so we're going to use summation notation. So you'll recall we use the capital sigma. And then we're going to want to find our general term, the general term of your sequence that we're going to sum up and create a series. So this is going to a sub n we'll use for our general term. And then we'll sum these from some, right, starting n value, k, j, pick a letter. And we're going to add forever, so add to infinity. Okay, so let's go ahead and practice. We're going to find our general term and write in that summation notation. Right, so my first series, so I have 1/2 plus 1/4 plus 1/8 plus 1/16. Right, so when we do our summation notation, your n value goes up 1 each time you go through. So this first one, and if, right, you're kind of having, it's like, right, you're not quite sure what to do, you can write what the n values are for each of those terms. And you don't necessarily have to start at 1. In fact, we're going to have an example here soon where we start at 0, but we're just going to make them start at 1 and then figure out what has to come next. Another good strategy is just to come up with the next couple of terms to figure out how, right, because probably, right, you're good at math, so you know what the next term is in the pattern, but maybe you don't know how to write it down, and the more you think of what those terms will be, the easier it is to write them. Okay, so let's go ahead and we'll write summation notation, right? We're going to start from 1 to infinity, and let's see, what am I doing there? These are all, 2 to the n on the denominator, and the 1 stays on the numerator. So 1 over 2 to the n, summing from 1 to infinity. Cool. Okay, how about this next one? Okay, so let's see. Here's n equals 1, n equals 2, n equals 3. Okay, I see it. Do you guys see it? Okay, so again, summing from n equals 1 to n equals infinity, and that looks like 1 over n squared. Okay, this last one, this is called an alternating series because the sign, the sign alternates between, right, positives and negatives. This is an alternating series. So let's see what we're going to do for that one. So we'll go ahead and start from 1 to infinity. Let's see, here's my n equals 1, n equals 2, n equals 3, n equals 4. So to make the sign change back and forth, right, so that's going to be an exponent. And it looks like for my odd ones, that's when I have positive. So the way we do the alternating part is we use a -1, and we're going to raise it to a power so that when, right, it's an odd power, it's positive, and when it's an even power, it's negative. Okay, I said that wrong. We're going to do it so that when n is odd, it's positive, and when n is even, it's negative. Okay, so if I do this to the n plus 1, that should take care of it. So if n is 1, this will be -1 squared. That'll be positive. If n is 2, that'll make this power here 3, so I'll have -1 cubed. That'll make it negative. Okay, so that's good. So I've got the alternating part. So now then, let's get the rest of that. So there are a couple of ways you can do an alternating, right, pattern, right, going up by the odd numbers. So 1 stays on the top. I'm going to do this, so, and you can always check your first couple of terms and make sure. So 2n minus 1, I think, is going to get me all of those fractions. So let's see, if n is 1, I have 2 times 1 is 2, minus 1 is 1. So this part here is 1. I know that this is making it positive, so that gets me the first one. Let's check n equals 2. So 2 plus 1 is 3. That's an odd power. That'll make it negative. Good. I've got my 1. N is 2, so 2 times 2 is 4, minus 1 is 3. I get my next term. Right, you can go ahead and verify that it works for those, the 1/5 and the -1/7. Okay, so that's taking a given series, writing it in summation notation by finding the general term. So this is our general term. Okay. Now, one of the things that we're going to need to do, right, is we're going to want to find what these sums are. What do they add to if we add, right, an infinite series? And the first thing we look at are these partial sums. So a partial sum, so we use capital S's. So S sub 1 is just the first term, right, the first series, so A sub 1. S sub 2 is A sub 1 plus A sub 2, right? It's just the sum of the first two terms. S sub 3, I know you know, right? Plus A sub 3. So we're going to make like a sequence, right? A list of numbers of the partial sums. So S sub capital N, make this capital, I want to distinguish it, is A sub 1 plus A sub 2 plus A sub 3 plus, until you get out to that, plus A sub capital N, that last term, right, that you're going to actually look at. And the reason why we're going to look at these partial sums is that's how we're going to check whether our infinite series is going to converge or not. So we will say that an infinite series, so starting at k, so I'm being arbitrary here, start at wherever you need to, but you're going to add out to infinity, that equals s if the limit of the so n goes to, capital N goes to infinity. So if the limit of those partial sums goes to s, okay, so we're looking at, right, all of these partial sums, right, we keep adding on those extra terms of a. If it looks like these partial sums are converging to the number s, then we say that the series converges to s. Now, if they don't, if your partial sums do not converge, then we say it diverges, right? If the limit doesn't exist. And you might be more specific and say that it diverges to infinity, right? If the sums increase without bound. Okay, so that's kind of a general overview of an infinite series. Now we're going to talk about, right, a couple of properties, and these are similar. You've seen these with a lot of your math things, right? And it falls under that whole the linearity. So series are, right, linear. They behave linearly. So that means, right, if you have, right, two series, A sub n, B sub n, and they both converge, then, right, I know you know what's going to happen, right? You can do the sum or the difference, so plus or minus, right, the two series, and that will also converge, and you can just do the sum of A and then plus or minus the sum of B. So this is just a little shorthand, so I didn't have to write out one for the sum and one for the difference. So if it's plus on top and it's plus over here, then those two go together. Minus, right, when they're together is minus when they're apart. And then this, C is a real number. Right, so this is just the constant multiple, the coefficient. And just like with a lot of things, this means the coefficient can just pop out in front. All right, now we have a couple of special series that I want to talk about, and the first one is a geometric series. So you might remember, right, geometric series means there's a common ratio, and we're going to use the letter R. Sometimes it'll, well, I guess R is the most common. So this is what we're going to start with. So we're going to start at 0. Remember I told you 0 was coming up. So from 0 to infinity of C times R to the N. Let's write out a few terms. Let's see what this is going to look like. So if C is 0, I'm sorry, if N is 0, I have C times R to the 0 is 1. So I have C times 1, just C. And then my next term, I have C times R to the first. So C times R. And my next term is C times R squared. So each time, right, I go up, I multiply by R. Right, the term before times R, right? So plus CR cubed plus, right, dot, 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 all the way out. Okay. Now, what this equals if it converges, it converges to C over 1 minus R. Fantastic. Now, if the absolute value of R, remember R is that constant ratio, if that constant ratio is greater than or equal to 1, then your series diverges. If R is less than 1, it converges to, right, that C over 1 minus R. Now C, it does not have, well, okay, it is going to be a constant. C, though, is the first term. So don't worry if your terms don't start off, right? If your general term doesn't feel like it's an n equals 0 or an n equals 1, we're just going to let C, right, because of how we have it structured, here, right? If n equals 0, that first term, right, can be your C value, and then each time you build up it, you just multiply in an additional R. All right, so let's just take a look. I have a couple of examples here. So we're going to find the sums, or we're going to state that the series diverges. Okay, so, right, I know you could write in the next term over here, right, 2 to the 5th over 3 to the 5th, etc. Right, so each time, right, what's our constant ratio? How do I get the next term? Right? I multiply by an additional 2/3, right? Okay. Well, what's our first term? What is C? That first term is this 2 squared over 3 squared. It's just 4/9, right? 2 squared over 3 squared. And if that's your first term, right, it's okay. If that's your first term, your next term is this, right, 4/9 times an additional 2/3. So as long as you have your starting point of 4/9, right, then you can get, right, each term after that, right, goes up by, right, a ratio of 2/3. So what does that sum equal? So our sum equals C, 4/9, over 1 minus R, so 1 minus 2/3. So just doing that arithmetic, 4/9 over 1/3, flip and multiply, 4/9 times 3 converges to 4/3, right? Which is just amazing, right? You're adding up infinitely, and it will come to a finite value, right? Its limit comes to a finite value of 4/3. Okay. How about this? I'm summing from 0 to infinity, e over pi to the n. So you could write out some terms. So your first term is, right, 1, and your next term would be e over pi, and then, right, e squared over pi squared. So I'm going up by the same ratio each time, right, multiplying by e over pi, and you keep doing that forever. Does it converge or does it diverge? So, right, what is R? Right? E over pi. Is that greater than 1 or less than 1? Right, well, E, right, is about 2.7 something, and pi is about 3.1 something. So this is less than 1, right? So it does converge. And what does it converge to? C. So C is, right, our first term. So that's 1 over 1 minus the ratio, e over pi. I'm just going to leave it like that. You could tidy that up, multiply top and bottom by pi. Okay, I will. I hear you guys out there. So pi over pi minus e, if you don't want to have a complex fraction in your answer. Okay, last one. So write out your first couple of terms. So I get to start with a 1 again. Right? And now this time I've just flipped my fraction, so pi over e, right? Plus pi squared over e squared, plus dot, 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 dot. So what's my ratio this time? Right? This time it's pi over e, is that we're multiplying by each time. And my e starting to look like a row, sorry. This is actually greater than 1, right? Because the numerator is larger than the denominator, so this series actually diverges. It does not converge, right, to a number. Okay, I want to show you one more series in this video, and that is a telescoping series. Now, telescoping series, sometimes they're easy to spot, and sometimes you have to do a little work to recognize them. So this first one, and really the easiest way to see them is if you start writing out the terms. So let's write out some terms. Okay, so if n equals 1, I have 1 over 1 minus 1 over 2. Now I'm going to add, right, I'm going to add in my next term because we're summing, but I'm going to put it in parentheses. So we're going to add on, so now n equals 2. So here was n equals 1. Here comes n equals 2. So I have plus 1/2 minus 1/3. Okay. Plus, here comes my n equals 3. N equals 3, I'm going to get 1/3 minus 1/4. Well, what's going to happen there? Right? Do you see everybody canceling out? So I have a minus 1/2 here, but then it's going to add with a 1/2 there. Right? My minus 1/3 and my plus 1/3. So let's say, so plus dot, dot, dot. Let's write out that nth term there. Right, so it's going to be plus 1 over n minus 1 over n plus 1, right? Well, this 1 over n is going to be canceled with a minus 1 over n from the term right before it. So all I'm left with is this minus 1 over n plus 1. Right? And if you keep going, right, they'll just keep telescoping in. I think of those like collapsing cups. Have you ever seen the camping cups, right? Where it just goes, you can push it down and it goes flat. Right, so that's kind of happening here. They're going ching, 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 ching. So you'll just get your first term and your last term. Okay. So the way we find the sum is we're going to take the limit then of just that last term. So I'm going to take the limit as n goes to infinity, right, of my series. Okay, so then it's 1 minus 1/2 plus 1/2 minus 1/3 plus 1/3 plus dot, dot, dot plus 1 over n minus 1 over n plus 1 over n plus 1. Right, so all of these interior terms cancel. I don't have anything to cancel the 1 over n plus 1, but as n goes to infinity, that term goes to 0, and all I'm left with is 1. So this telescoping series sums up to 1. So let's do one that we have to do a little bit longer on. We're going to use partial fractions, and we're going to rewrite this interior, and it's going to create a telescoping sum, or telescoping series, and then we're going to see what it converges to, if it converges. And let's see. So partial fractions, just to practice. So 1 over n times n plus 3. Remember how we do this. Right, so an a over n plus b over n plus 3. I'm going to go ahead and multiply through by the common denominator. That's my strategy. So that I have 1 equals a times n plus 3 plus b times n. And I'll check this at n equals 0. So at n equals 0, I learn that a equals 3n, or a equals 3. There we go. So a equals 1/3. And now we'll check b, and to do that, I'll check n equals -3. So then I have, I'm just looking here, I have 1 equals, right, it's a times 0. I'll write out another step since I missed that last time, times -3b. So 1 equals -3b equals -1/3. Okay, so my original fraction I can rewrite as 1 over 3n minus 1 over 3 times n plus 3, right? So there's my b and there's my a. Okay, still with me? Okay, so now I'm going to come down here on the very bottom. So I'm going to copy that series real quick. And then I'm going to slide my page. Don't worry, I'm going to slide. Here we go. So that equals 1. Oh, you know what? I'm actually going to factor that 1/3 out. Remember our linearity thing? It says that this 1/3 that's on both can come out front. And now I'm adding 1 over n minus 1 over n plus 3. And n goes from, where did I start? There we go, 1 to infinity. So here we go. 1/3. I'm going to write out a few terms, okay? I'm just going to see what it looks like. So I'm going to get n equals 1. I have 1 minus 1/4. Here comes my n equals 2. And there's n equals 1. N equals 2. I won't use the parentheses this time. So now I have 1/2 minus 1/5 plus, here comes my n equals 3, 1/3 minus 1/6. Nobody's canceling yet. Oh my gosh, I hope everybody goes away here soon. Plus, here comes my n equals 4. Oh, there it is, 1/4 minus 1/7. Oh, running out of room. Okay, so now I have my positive 1/4 and my negative 1/4. So those guys will go. There's my n equals 4. Let's do an n equals 5, just so that you see that they're all going to go away. So here comes my n equals 5. So I'll get plus 1/5 minus 1/8. Okay, there's the positive 1/5 to cancel that negative 1/5. Then I'll get a 1/6. That'll get rid of this 1/6, right? So now everybody else should cancel out as we keep on going out to, right, plus dot, dot, dot. And then that negative 1 over n plus 3, right, that last term that we decided to write. Okay, I totally ran out of room, so I'm just going to scrunch it up right here into the space. So I'm going to gather up everybody who's left. So I have 1/3. I have a 1 left. I have a plus 1/2 left. And I have a plus 1/3 left. Sorry, I'm covering it up. Everybody else, all my other terms are going to cancel. And then I have this minus 1 over n plus 3. And we take the limit, right, as n goes to infinity. So that last term goes to 0 because all I have is an n on the bottom. So what's left there is my sum. So my sum does converge. So 1/3 times 1 plus 1/2 plus 1/3. Are we going to do it? Sure, let's do it. Okay, so inside here, common denominator is 6. So I'll have 6 plus 3 plus 2/6. So that is 9, 10, 11 sixths times 1/3. So that looks like 11/18 is the sum of this telescoping series that we had to do partial fractions on and then write out all of those terms. Super fun, right? Okay, have fun.